Hello and welcome to this overview of SOLIDWORKS Composer 2013. During this presentation, we'll show how SOLIDWORKS Composer leverages existing 3D engineering data to author rich technical communications. These include a variety of things, such as technical publications, parts lists, operational step-by-step procedures, animations, and more. During this presentation, we'll be leveraging the Resman Bolter 77D. This vehicle is used to secure the walls of a tunnel after it's been drilled with a mesh-like structure. Resman wants to ensure that it delivers their customers the best experience when it comes to their final deliverable content. This includes things such as their owner's manuals and other online content. During the course of this presentation, we'll be covering several key areas. We'll start by taking a look at the content that's already been created. Then we'll look at how SOLIDWORKS Composer leverages existing 3D data. We'll go through the process of creating our own parts list, step-by-step procedures, and adding some interactivity to our designs. And finally, we'll see how SOLIDWORKS Composer allows us to publish this content. So let's go ahead and get started by taking a look at some of the existing content already created. When we think about technical documentation, one of the first things that comes to mind is traditional tech pubs, things like owner's manuals, which come with many of the products we purchase today. And the same holds true for this Bolter 77D. The owner's manual for this document contains several key pieces of information, such as diagrams which show the operational characteristics including turning radius, height restrictions, and so forth for when it's driving through a tunnel, and also detailed breakdown of parts. During this presentation, we'll be working on the boom assembly on the front. Now this content was created using SOLIDWORKS Composer here and is a detailed breakdown of any of the replacement parts. However, SOLIDWORKS Composer allows us to create even richer content. When working with a vehicle such as this, there's a lot of information available. And though this might look like a static 2D image, we can see right away that it's much more than that. In fact, we can rotate the model around and zoom in on key areas. Furthermore, there's several key areas that we want to focus on, including creating an interactive purchasing list for replacement parts for high wear items, maintenance procedures for other wear items which might need to be removed and replaced, and finally, we want to highlight some of the operational features of this vehicle. So let's go ahead and take a look at the replacement parts guide. As we click on the image panel, we're brought to another image. And like before, it's not just a static 2D image, and it is in fact a 3D model that we can rotate around. This makes it easy to find the parts we're looking for. Also, several of the components highlight when we hover over them, such as this main drill boom assembly. We can click on it to dig further down into the assembly to find just what we're looking for. And we can continue to drill down into the components until we get to the rotational unit. Now, 3D is one way of being interactive with the content, but other things are very apparent here as well, such as the parts list is interactive and provides cross-highlighting. Once we find what we're looking for, we can drill down just to the part we're looking for, and because we're working in 3D, we can even rotate it around to verify that it is in fact the right part. Then all we need to do is add it to the cart and purchase it. Let's go ahead and return back to the main view. Now we'll take a look at the maintenance procedures. There's a few that have been created, including removing the boom cylinder and the drill head replacement. There's also a controls overview, which is great for new operators to get an understanding of what each of the levers does on the control console. And because we're in 3D, they can navigate around to make sure they understand what they're looking at. Let's take a deeper dive and look at the drill head removal procedure. Like before, there's a hyperlink to navigate directly to it. This is a high wear item and there's several steps involved, and we can see that SOLIDWORKS Composer uses a combination of graphical elements such as arrows, colors, and textual callouts to make it extremely clear which steps need to be performed. We'll go through a few of these processes to see how exactly we get to lowering this drill assembly. At certain points, we'll see that there are clear advantages to working in 3D. This image, for example, might be hard to see and understand in a 2D document, but because we're working in a 3D environment, we can simply rotate the view around and get a clear understanding of what needs to happen. Once we've verified the process, we can continue on and remove the drill head off of the end of the boom. The last thing we'll take a look at are some of the operational features of this vehicle. There's some that are very unique. Across the bottom are some thumbnails that we can click on to see how the individual features work. Here, for example, we can rotate the placement boom through its range of motion. And again, because we're in 3D, we can zoom in to get a clear view at how these stabilizing feet work. There's a really neat feature of this vehicle, how it steers through the tunnel. It actually rotates the back end of the vehicle. And again, we can see that clearly here using this document. So we've taken a look at several pieces of content that have already been created with SOLIDWORKS Composer. We've seen how it can be used to assist in the creation of technical publications and create interactive experiences right inside of a web browser. They're graphically interactive, they provide a true 3D experience, and they're clear and easy to understand. The next thing we're going to take a look at is how SOLIDWORKS Composer leverages our existing engineering data and some of the rendering and graphical capabilities of SOLIDWORKS Composer. We'll start by taking a look at where the data comes from. Here we're going to navigate to our design tool of choice, SOLIDWORKS, and here we can see the boom assembly that we'll be working with throughout the rest of the presentation. So let's go ahead and close this, as well as any other open documents we might have. We're not going to need these anymore, as we're going to create everything from scratch. Once inside SOLIDWORKS Composer, all we need to do is choose File Open. From the File Types drop-down, we can see that SOLIDWORKS Composer supports a wide variety of native CAD formats. In our case, we're working with SOLIDWORKS, so we'll simply select our assembly, and SOLIDWORKS Composer will get to opening the file. SOLIDWORKS Composer not only imports all of the three-dimensional data, but also the meta properties or custom properties in SOLIDWORKS that we've incorporated into the design process. It's important to note that we're not making any changes inadvertently to the original engineering data either. Once the geometry is open, we can see that initially it's of course in 3D. We can zoom, pan, and rotate, but we've also gained many other valuable features, such as preserving the entire assembly structure. And here in the bottom, we can see all of the properties that have come across with these components. Let's go ahead and take a minute and get a quick understanding of the user interface. It's much like many Windows applications in that there's a ribbon toolbar across the top with tabs for discrete operations. This makes it easy to find the tools that we're looking for. Graphically, there's many settings we can adjust as well. We've already seen the grid on the floor, but there's also the ability to enable a mirrored surface and shadows. Per pixel lighting is a great way to make the image pop, and ambient occlusion will add some really nice shadows to our model. Once you set up the model the way you like, all we need to do is save it as an image or a view and give it a name. We'll call this default, as this will be our home view like we had in the HTML file. While we're here, we can also look at a few of the rendering styles that are available. Some of these represent more traditional technical illustrations. Technical is a nice colorful way that you would typically see in illustrative documents. Flat technical is a nice way to discreetly separate colors from each other. And silhouette really represents that more traditional tech pub style. We can also change any of the edges and how they outline. For example, we can remove all but just the sharp corners. We can also turn any tangent edges into a single entity, or in our case, we'll use the traditional show tangent edges style. We've looked at several graphical elements. Let's do a quick recap and see where we're at. We've seen how SOLIDWORKS Composer can natively open a variety of CAD formats and work in its own independent environment, meaning we're never actually manipulating the original engineering data. The full assembly structures are supported, as well as the meta properties that are incorporated into the designs. We've seen that SOLIDWORKS Composer has a familiar and intuitive user interface, and that there's a lot of graphical styles and choices that can be applied. We want to dive right into creating our content now, and to do this we're going to create one of those interactive parts lists that we saw in the HTML file earlier. Through this process we'll show how we'll manipulate the 3D geometry, create the interactive parts list, and add callouts to our design. We'll also see how working with SOLIDWORKS Composer is affected by engineering changes that happen in the design lifecycle. So let's go ahead and dive in. Like the default view that we created before, the first step we're going to want to do is create a starting point, or our original image. Once we've done this, we can give it a name and we can start getting to work. Working with the geometry on screen is quite easy. We simply select it, and from the pop-up right at our cursor, we can immediately start manipulating the geometry. In this case, we want to explode several components. And one of the things you'll notice is that when I grab the components, I can also choose edges and axes to move them by. Not only can we select any of the geometry on screen, but we can also select it directly from the assembly structure as well. This is nice when we want to grab several full subassemblies and do a move operation to those. So we've exploded our components, and the next thing we want to do is we want to create the parts list itself. To do this, we're going to use one of SOLIDWORKS Composer's many workshops, the BOM workshop. Once it's open, we'll go ahead and push pin it in place, as we'll be spending a little bit of time here. To create the parts list, we want to select the items on screen we want to include. Now we could do this graphically right from the graphics area, or we could use the assembly tree again and use traditional selection methods such as doing a shift select. Also, we can independently or discretely select the top level subassemblies to make sure that they get their own item number and not any of the subcomponents in them. Once we've selected all the components we want, we simply tell SOLIDWORKS Composer to generate unique IDs for each of the components. You'll notice that as soon as we do this, a parts list appears at the bottom of the screen. Several of the columns are missing some key information, however, such as part number and description. Let's take a look at where this data comes from. SOLIDWORKS Composer initially extracts the information from some meta properties in the engineering data. Here, we can see a list of all the meta properties that were supplied. In our case, we'll use part number. You can also rename and reorder the columns any way you like to make sure the parts list appears the way you want. If you remember the parts list in the HTML earlier, it had cross-highlighting enabled. When we hovered over an item, it would highlight the appropriate components on screen. These are controlled from the properties over on the left-hand side. Enabling it automatically makes cross-highlighting work. We can also control how the bill of material works and is positioned. For example, we can set it to a free position, or in our case, move it over to the left-hand side. Once we have everything set the way we want it, we'll want to make sure we save this view, and let's save the document. Now's a good time to talk about engineering changes. We've already started the documentation process even before the final design was finished. Here, we're going to go over to the engineering tool and make a few changes, because we want to see how these impact the documentation environment. Inside of SOLIDWORKS, we'll make a few minor changes. We'll go ahead and turn on a few of these knuckle kits which hold the hydraulic cylinders to the main support bracket. We'll also change the cylinder guard component to the latest revision. This might be done with Enterprise PDM or by making simple revision changes to the models themselves. Regardless, engineering changes take place. When we return to SOLIDWORKS Composer, all we need to do is choose Update and then choose the assembly document from SOLIDWORKS. SOLIDWORKS Composer then goes through and looks at the entire assembly for any changes. This means that we can start the documentation process early on in the design cycle, and as changes occur, we simply need to choose Update. Once SOLIDWORKS Composer finds any changes, it'll add the components and change the geometry and update our views. Here we can see that the parts list now includes the knuckle assemblies. Also, the default view contains them now as well. Furthermore, if we go and look at the assembly structure, we can see that each knuckle kit has been added. Let's get back to what we were doing before and select the two knuckle kits and give them a unique BOM ID so that they appear in our parts list. The next thing we'll want to look at doing is adding callouts. To do this, we'll just simply select all of the components and choose Create Callout. The callouts that are created are intelligent, and you can see that they try not to overlap each other. We can also display them in a variety of ways, including parametric, where they hug tight to the parts, or we can change to a rectangle style where the balloons are around the component, or in our case, we'll set them to top and right, as this appears very clean. Now, We'll go ahead and update this view, but I want to take a deeper dive at how we create things like exploded views and add trail lines. To do this, we'll create a new view of that knuckle kit that we've just added to the design. Once we're in here, the first thing we'd like to do is remove any of these unique BOM ID numbers so we can reuse them. We also want to isolate just the knuckle kit by itself. There's some great selection tools that allow us to hide all the other components except for what we have selected. Now we go ahead and get into moving the components using tools like the linear transform we saw before. Here we can see that using the Tab key hides components out of view, making them easy to select. Sometimes, however, we want to grab more components than just what's on screen. We saw this a little bit earlier, but again, let's take a quick look at how we can select assemblies right out of the assembly tree. Now sometimes we move components and we don't get everything we're after. Another great tool for this is to transform based on the position of another component. It makes sure that if we miss anything, we can always go back and make changes. Now let's take a deeper dive and look at some more advanced tools for doing these procedures. On the Transform tab, we have a tool that allows us to quickly do linear explodes. All we need to do is select a series of components, and the components are spaced evenly apart. We might want to grab these and make minor adjustments to them afterwards, and we do this using the same tools we've been using all along. In fact, you'll find out we use the linear transform and rotational transform tool quite a bit as we go through the demonstration. They're the key fundamental tools you'll be using throughout the process. But as you can see, the process is simple and straightforward. We select the components and use the explode tool on them, and then make any adjustments with the linear transform tool. Once we have all the components where we want, we might want to add some trail lines to clearly show how the components go together. For this, we'll use the Polyline tool on the Authoring tab. It's a simple tool where all we need to do is select some geometry and draw a line out. It snaps to the center of any of the objects on our screen, making it easy to place. And again, we can rotate around and get the orientation so we can draw the lines easily. So we've created the lines, but they don't quite look the way we want. They're red, they show through all the other components, and this is another case where the properties on the left-hand side come in. Here we can change things such as whether or not it stays on top, the color, and the line font as well. We don't want to go through that same process for every line we create. Styles are a great way to capture company standards. All we do is select an entity we'd like to capture its style from and create a new one. Then select any entities we want and apply the style to it, and even set it as the default. So we've created our trail lines, we've exploded our components. We're just going to go through the process we did before of generating BOM IDs, showing the table, and creating some callouts. Now we could use the automatic callout format we did before, but I'd like to show some other tools. So we're going to set these balloons to what we call free 2D. We're going to do this to show a great feature called the magnet line. Magnet lines are entities that we can use that snap to different entities on screen. We just drag it and they snap together. This is a great way to position things like callouts or other components or views on screen. And as we manipulate them, we can see that these callouts stay attached to it. They also stay equally spaced, so if I want to move or change the position of these, they immediately line back up. We can also make sure that the magnetic line is aligned to geometry on screen by simply selecting this little glyph on it and then selecting the appropriate geometry, such as the edge of this hex head bolt. We can also change the position of where any of these annotations connect to these parts. So we're not stuck with what SOLIDWORKS Composer creates automatically for us. So if you want to change the positional placement of any callout, feel free to drag them around and customize them as much as you like. The whole idea of SOLIDWORKS Composer is to get just what you're looking for. We've finished creating this image, but what can we do with it? We'll see some things we can do later, but right now we want to look at publishing this for use in things like an illustration tool, such as Adobe Illustrator. To do this, we'll activate, again, one of the workshops inside of SOLIDWORKS Composer called Technical Illustrations. In the workshop are a variety of options which affect final output, such as the line styles, how shadows appear, and even the hotspots we saw earlier, and some standards. Once it's all set, we simply choose Preview and we can see the scalable vector graphics image. As we hover over the items, we can see that they cross-highlight just as we enabled it in the BOM. And because they're scalable vector graphics, we can resize this image any way we like, and the geometry will update accordingly. Let's pause and do a quick recap of everything we just saw. We saw that it was easy to manipulate and move the geometry anywhere we wanted on screen. The parts list was created automatically and it was fully customizable, as well as those trail lines, using the properties on the left-hand side of the screen. We were able to handle an update from the engineering software quite easily, allowing us to start the documentation process very early in the design cycle. We also saw that we had support for styles that are unique for things like company standards, and we saw that we could publish out to a scalable vector graphics format for use in tools such as Adobe Illustrator. The next area we want to look at are creating things like step-by-step procedures or assembly removal instructions. To do this, we'll be using tools similar to what we've seen before, but we'll be working in a little bit of a different format. Finally, we'll show how we can output these as high-resolution images for use in other types of documents, and also how to create an animation. Like we've done in all the other processes before, we're going to want to go ahead and set a start point, and this will include some graphical elements. For this example, we're going to change to the flat technical style, as we're going to use colors as a key element for calling things out. We're going to set the initial start point, where the process will begin, and then create our first step. It's very similar to what we did before in that we're going to be selecting components and using very similar, or in fact the exact same tools that we used before, such as Linear Explode. A few of the key differences, however, might be how we move these components around. We're going to be selecting geometry to make sure that they pull off in a specific direction. We're going to use the properties that we saw earlier to change the colors of these components so they really stand out. As you can see, we're using all the same tools we used before, but let's introduce a new one. The arrow tool is a great way to graphically describe a procedure. We simply select an entity, drag an arrow out, and then move it around. And like anything else we've worked with in SOLIDWORKS Composer, there's things that we can change. In this case, the size. We can also add callout labels. This is a nice way to textually describe the operation. For example, we might want to specify that we need to remove the expander pin hardware here. When we create the note, we can also do things such as add additional leader attachments to all the components on screen. We do this by simply dragging them out of the manipulator on the note itself. Then finally, we just set the view the way that we want it and update it and create the next one. To begin, we simply need to hide the items from the previous view. To do this, we'll just select them all and press H. And then we'll show how to retract this hydraulic cylinder. Again, using the same linear movement tool that we've used before, we'll grab this cylinder and move it along its axes. We'll also want to change the color properties as we did before to highlight this component. And again, we'll graphically add an arrow to this to describe the process. Now we'll want to change the orientation for this view to get a clearer look at it. And we can see that the cylinder guard gets in the way a little bit. There's some other graphical manipulation tools we can use from the right mouse click menu. We could just hide this component, but ghosting is a more effective way to show that the component is still there. When we go on to the next step, all we'll need to do is unghost the component. And we'll hide the arrow in this case as well, because we won't need it for this procedure. Now most of the stuff we've done up until now has been linear movements. The same can be done for rotational operations by simply choosing rotational transform. In this case, we're going to rotate the cylinder out of the way, and we're going to go ahead and add an arrow to call this out as well. The circular arrow is a little bit different in that it's intelligent and automatically snaps to circular geometry. However, it functions much like anything else in SOLIDWORKS Composer. We adjust the properties to get it to look just the way we want. In this case, I want it to have somewhat of a flat style, and we want to change where the endpoints of this arrow are located. There's also a manipulator available to quickly change its scale to make sure that it appears proportionally correct. So again, we finish this procedure. We'll go ahead and save the view and move on to the next step. Now, we'll want to change the color of this cylinder back to its original color, and this is done easily by restoring its neutral properties. This means that we can graphically change any elements and restore them back to the way they were before without having to remember all those settings. There's 2 steps left to go, and they're going to use the same tools we've used up until now, doing things like linear explodes and linear transitional movements. Finally, we'll also want to change the colors of these components. The key idea here is that SOLIDWORKS Composer makes it extremely simple to manipulate the geometry on screen and move it exactly where you want it. You can also add as many graphical elements to call out the operation that you're trying to perform. We've done this using things like linear and circular arrows to describe these processes. This hardware has been exploded out. We'll go ahead, save the view, and move on to the final step in the process. Like we did before, we'll simply want to hide these components to get them out of the way, and we'll select the cylinder, and we'll go ahead and move it and then change its color. Now, likewise, you could go through the opposite of what we've done here to call out the procedure for reinstalling this hydraulic cylinder, but I think we've shown quite enough how we can do these types of step-by-step procedures. The next thing we want to look at is what can we do with this data. We know we're going to see it in the interactive environment later on, but I want to take a moment and look at the high-resolution image workshop. The high-resolution image workshop, much like the technical illustration, is a way to output images using some default settings. Here we can save out every image in our drawing, or we can simply preview it. These images can be saved in a variety of formats and used in things such as FrameMaker, Microsoft Word, or Microsoft Publisher to create very graphical types of technical publications. One of the other elements we want to take a quick look at is the ability to create an animation. Animations are done quite easily inside of SOLIDWORKS Composer. We'll simply leverage all of these views we've already created and drag them onto the timeline. This will create all the individual keyframes needed to go through an animation process. As we drag the last view out onto the timeline, we'll simply hit play to see our results. Though they might not be perfect at first, they don't take very much to make changes to them, but they get all the hard work done and out of the way. In this example, we can see that the cylinder guard is maintaining its transparency. An easy way to change this is to select all the keys associated with that part and delete them. As you can see, we could go through this process for the rest of the features and components in this document and make those changes quite quickly. Let's again take a moment to recap everything that we've just covered. We saw that it was easy to graphically control how objects looked on screen. This included things such as colors and their positions. We were also able to easily add descriptive graphical elements such as the arrows. The whole process was a very simple step-by-step procedure, much like what we were trying to show. We also saw that it was easy to bounce back and forth between graphical elements with a lot of tools available in SOLIDWORKS Composer. And finally, we saw that we could take these individual views and save them out as high-resolution images for other applications to create different forms of documentation. The last 2 steps we're going to take a look at, interactivity and publishing, really go hand in hand. Before we dive in, what we want to do is we want to create that immersive experience that we saw very early on. We want to make sure that our document is able to link from view to view and make sure that the customers get an enjoyable experience. So let's go ahead and take a look at how we'll add these elements to our project. To get started, we'll add a few more graphical elements to our view. SOLIDWORKS Composer comes with an image library full of icons that you can simply drag and drop onto screen, or you can add your own, such as the resin logo. Now, one of the really unique things about SOLIDWORKS Composer is the ability to link. We can select any object and choose the link property and associate it to things such as a website, an FTP, or even another view. In this case, we'll choose to link this Resman logo to the resman.com website. There's also several entities provided inside of SOLIDWORKS Composer that automatically contain this intelligence, such as the navigation buttons. Here we can see in the properties that they automatically cycle from one view to the next. Now, we don't want to go through the process of adding these entities to every single view. So one way we can do this is to simply select the entities we want to copy and then select all the views we'd like to apply it to. In this case, it's going to be virtually every view except for the first one. Once we've selected them, we simply choose to update those views with those items. Now, when we navigate over to any of the other views in our project, we can see that those items appear there correctly. We can also make any tweaks and adjustments if necessary. One of the other things we saw earlier was the ability to click on components and link over to another view inside of our document. To do this, we'll go into the assembly structure and select the two knuckle kits we added earlier, and we'll apply a link to the exploded view of the knuckle kit itself. To do this, we simply choose a view from the drop-down, and all the views inside of the document appear in the pull-down. Finally, we're going to want to go ahead and add some unique elements to the main default page. We want links that go to the parts list in the remove cylinder process. The easiest way to do this is to simply drag and drop these out onto screen. We'll also go ahead and add some labels to this. To do this, we'll choose the Text 2D icon from the Author tab. We'll simply give it a description, and we'll want to remove the border from this. And then we'll simply copy and paste this over and change the callout on it. Now, you'll notice I'm intentionally placing these items a little bit sloppy on screen. This is a great case where, again, we'll use the magnetic line. As soon as I place it, the items start to snap into place. One of the things we didn't point out earlier is the ability to turn off the uniform capability so we can adjust items along the magnetic line wherever we'd like. At any time, if you've missed any elements, you can go to the Collaboration tab and find any object we've created inside of SOLIDWORKS Composer and enable it manually. The last thing we want to do is add the intelligence like we did in the operational procedures, where when we clicked on an image, the components moved on screen. We're going to do this a little bit differently though. Let's go ahead and start by exploding these components like we did before. This is going to set the position of where we want this boom to appear in its extended position. We're going to use one of the other workshops in SOLIDWORKS Composer called the View Workshop to create a custom view. Custom views just capture limited elements of a view, making them somewhat intelligent. In this case, we only want to capture the location and the links associated with them. We'll call this extended and then move those components back to their home position. We're going to add a link so that whenever a user clicks on these components, it goes to the extended view we just created. And then we save all these settings just like we did before. Now, because this retracted view we just created didn't exist before, we'll need to go back to the extended view. You can already start to see how it's working. We're going to go ahead and add the link to the retracted version. So it's almost like we need to add a little bit of logic to our project. This is what's going to really create that experience where when we click on a component, it just moves on screen. Finally, let's go back to our default view and see how this works. Notice when we double click on extended, only the components that we had selected before move. Nothing else changes. So we finished this up. Let's go ahead and save our document. Adding the interactivity was actually quite simple. All we did was add some two-dimensional elements and add links to external sources and some of them internal. Basically, we were building navigation between the individual views. A lot of this was done automatically, and we also showed how to integrate custom views to give specific control over entities. The last thing we want to look at is publishing this document so we get that full interactive experience. This last step in the process is probably the easiest. We're simply going to publish all the hard work we've done and enjoy the results. Back in SOLIDWORKS Composer, all we needed to do is choose Publish from the File pull-down, and in this case we'll select HTML. We can see that SOLIDWORKS Composer provides a variety of default types right out of the box. We're going to choose Simple as we're going to utilize all the navigation that we've integrated. Now all we need to do is go ahead and open this. Once the HTML page is loaded, we'll be able to see all the results of what we did. Initially on screen, we can see that we have a three-dimensional model which we can rotate around. We can also click on the component that we had added here and choose to extend the boom, regardless of the orientation. That was due to the custom view we just added. The replacement parts guide that we created has the interactivity between the parts list and the components, and the linking from the knuckle kit to the subassembly is there. At any time we can navigate back to the home screen using the navigation we integrated and take a look at the removal of the hydraulic cylinder. Again, using the navigation tools we integrated, we can click through each step one by one to see how the cylinder is removed. Now, because we used the simple publish, a few things have been excluded, but they're available off to the side. Here we can turn on the ability to view the animation that we also created. Publishing was definitely the easiest part of the whole process we've seen thus far and yielded some of the best results. Let's take one last moment to quickly recap. Publishing was nearly a one-click process using some of the pre-created templates provided. It was completely web-enabled and it was easy to navigate for external users. And the best part, it was a full three-dimensional environment. We've covered quite a bit in the last half an hour. We've covered some existing content created with SOLIDWORKS Composer and saw how we were able to leverage engineering data from SOLIDWORKS and bring it directly into SOLIDWORKS Composer. We went through the process of creating an interactive parts list, a step-by-step procedure guide, where in both cases we created output for static two-dimensional technical publications. We then took it a step further and added some interactivity to our overall project and finally published it and enjoyed the fruits of our labor. As we've seen, SOLIDWORKS Composer is extremely easy to use and yields amazing results, ensuring that your customers get the best experiences when working with your products. I hope you enjoyed viewing SOLIDWORKS Composer as much as I've enjoyed sharing it with you.